Finding average rate of change if we're given some kind of word problem, real world context. So number one, in 2010, the population of a city was approximately 26,000 people. In 2015, the population of the city was 30,000 people. Find the average rate of change of the population. Now remember, when they ask you to find an average rate of change, that's basically the same thing as finding slope. And remember, the slope is rise over run, or change in y over change in x. So what you want to think about, when you find the rise, or the change in y, you're going to subtract y2 minus y1. Now that seems kind of weird here that, well, we don't have x, y points, but we really do. We have two variables, the time or the year, and the number of people in the population. So does it make more sense to say that the population is going to change in people per year or years per person or per people? So what makes more sense? If the population increased by, say, 100 people per year, or the population increased 1 year per 100 people? It seems more logical in our head to think about it as changing as people per year. So the population increased by this many people per year. That makes more sense. When you're going by gas, let's just say gas was $3 a gallon. That's how you look at the units. Dollars per gallon. You don't say 1 gallon per $1.2. Okay, so the units will help you decide what makes sense in the numerator and denominator. If that makes no sense at all to you, a lot of the time with a word problem, you're going to be given years and some kind of y value, like population in this case, or the percentage of something, or the height of something, or the distance of something. A year is always going to be the x value, which means it's going to go in the run or denominator. So if you remember nothing else, remember that years will be what you subtract in the denominator, if years is one of your variables. Okay, so getting back to this one, if we can recognize that people per year makes the most sense, well, what happened to our people? We went from 26,000 to 30,000. Now we know that went up by 4,000, right? So if we did 30,000, so like your y2 value, your second population, 30,000 minus the first population, 30,000 minus 26,000, over the 2015 minus 2010, that'll give you an increase of 4,000 people for every 5 years. And make sure that you pay attention to the signs here. Don't just assume that you're doing it correctly. You should remember that in the context of a word problem, what happened was the population went up. So that means we should have a positive slope. So that means that our calculations should either result in a positive over positive, which it does here, or negative over negative. And notice if we would have reversed the populations and the years, that would have given us negative 4,000 over negative 5. And that does end up reducing to 800 people per year. So hopefully if you were to hear that in a sentence, that the population of the city increased by 800 people per year, I think we would all have an understanding of what that means. So in 1 year, the population went up by 800 people. Okay, so keeping that concept in mind, not to spend 5 minutes on each of these, you can try the next one and I'll show you the answer. And when you read this one, notice that now the population decreased, which means we should have a negative slope. Okay, and if you substitute the values into find slope, we can see the population decreased by 2,000 people over those 5 years. So it's just kind of logically looking at, without even trying to look at y2 minus y1 and all that, just looking at what happened. the population went down by 2,000 in 5 years, which is negative 400 people per year. So that would just be saying the population decreased at a rate of 400 people per year. Using the math formula, y2 minus y1, the ending population minus the starting population, or the earlier population, divided by the ending year minus the starting year, gave you a positive 5 years and negative 2,000 change in population. Okay, and then moving on to the next one. Again, read the question, and then think about, does it make more sense to say that his salary went up or down by this many dollars per year, or his salary changed by years per dollar, like 3 years per dollar? That doesn't really make a lot of sense. So that tells you that the money, dollars, should go in the numerator, and the number of years that went by should go in the denominator. So try that, and I'll show you the answer now. So it looks like his salary increased by $1,100 per year. The salary increased by $3,300 in those 3 years. Okay, moving along to the next one. Pause the video and try it. Here, if you're looking at the rate of change of the percentage, it should make sense that the percentage of people who supported legalizing marijuana changed at this many percent per year rather than years per percent. So percentage should be in top in the numerator and the years in the denominator. So when you do those calculations, the percentage increased by 14% over those 4 years, which is a positive 3.5% per year. And again, notice that's a positive percentage because the percentage went from 32 up to 46. So that should be a positive rate of change or positive slope. And then the last one, at 4 months old, the baby's 21 inches long. At 8 months old, the baby's 23 inches long. Find the average rate of change of the baby's height. So think about, does it make more sense that the baby's height changed at inches per month or months per inch? So think about what makes more sense there and try it. So here I would suggest that it makes sense to say the height increased by 2 inches over those 4 months, which reduces to 0.5 or 1/2 inches per month. So that's how you look at finding a rate of change or slope when you're given some kind of real world context. And again, I think it really helps a lot to look at the units, meaning inches per month, percent per year. Think about what makes sense, and that'll tell you what to subtract in the numerator and denominator. And when all else fails, remember that time will go in the denominator. So again, in number 4, you're given the years 2015 and 19. That's what you subtract in the denominator, because things usually change over time, like percent per year, inches per month, dollars per year, that's changing over time, and so on.